Okay, this is today's PowerPoint. I am going to cover, this is for 0324 and 1324. I am going to cover writing logarithmics into exponential equations and solving exponential and logarithmic equations. Okay, these are the topics that I'm going to cover today, but let me start the slideshow. There we go. So these are the topics that I'm going to cover today. I'm going to writing logarithmic equations into exponential equations, writing exponential equations into logarithmic equations, solving exponential equations by using the same base rule, solving exponential equations with different bases, and solving logarithmic equations by using the logarithm properties. Okay, now writing exponential equations into logarithmic equations and vice versa. Okay. So for example, this is a definition of logarithms to base A. If you have y equals to log base A x means a to the y equals x. So this is how you convert, say, logarithmic to exponential and exponential to logarithmic. Example 1, write each logarithmic equation into an exponential equation. So what's given is log base 9, 81 equals 2. Okay, so all you do is you put the definition right underneath it. Okay, the log of base a x equals y. So then all you do is match the values, right? So you want it to go from logarithmic to exponential. So you have to know what the a is, the y is, and the x is, right? So I'm going to put a, x, and y. So the a is 9, the x is 81, and the y is 2. So this becomes, right, so my a is 9, my y is 2, and my x is 81. That's all you have to do. Okay, so going from logarithmic to exponential. Now going the other way, example 2. I just gave one example, guys, because this is kind of by using the rule, all you do is apply the definition, and you'll be able to actually work it out. Okay, this is example 2 is 5 cubed equals 125. And now you're going to go from exponential to logarithmic equation. So you have to go from a to the y power equals x equals to y equals to log of base a to the x. So you have to know what the a is, what the x is, and what the y is. If you notice, the a is equal to 5. My y, right, my y is down here. My y equals 3. And my x equals 125. So what's my y? My y is 3. And my a, right, which is the base, is 5 from here. And my x is 125. A lot of students get confused because they say, well, can it be done the other way, like log of base 5, 125 equals 3? Sure, it can. You see, these two are equal. So it doesn't matter how you write it. Both answers are correct. They're the same answers. Okay, now, why is this important, going from log to exponential and vice versa? Because for you to graph without a calculator a logarithmic equation, you have to know how to convert the logarithmic equation into exponential. That's the only way you can do it without a calculator. Okay, so I put here, in order to graph without a calculator, must convert logarithmic equation to an exponential equation. So the next thing that I'm going to cover is like a little review stuff or material that you learned in section 4.1. All this is from chapter 4, but it's too much information to go over in 1 hour. So what I'm going to do, just give examples of exponential functions. That's an exponential function. That's an f of x is an exponential function, so is g of x. Exponential function means that the exponent is a variable. You see, that's the exponent is a variable. That's the exponent is a variable. And here, guys, what I mean by recall, because this is something from, I believe, 0324. How you convert the exponential into a radical expression and vice versa. So what I mean here, guys, that the exponent can also be a fraction, but it has to have an x in it. I mean, it has to have a variable. Okay, that's what it means. And I put recall because this is also crucial for later on. A is called my base, and the exponent is a variable, right, or a letter. Frequently, it's going to be an x, or it can be a y. It can be any letter, but most of the time it's x. So that's a function. F of x equals to a to the x. Okay, now. So I'm going to cover also. I'm going to do one graph. I'm going to graph this equation here, okay, because it's crucial when you're going to graph a logarithmic equation, you have to convert it to an exponential equation, and by using the rules that we used earlier, okay. So example 3, how do we graph f of x equals 2 to the x power? First, you have to find some values, okay? So find f of x when x equals -2, -1, 0, 1, 2, and 3. So in other words, we're going to do a little table, right? F of x is the same thing as y. So I'm going to plug in all the values for x, then -2. When x is -2, right? I'm going to plug in -2 where the x is, right? So I'm going to find f of -2, which means 2 to a -2 equals 1 over 2 to the second power, which is 1/4. And I believe you guys are doing this in all 3, 2, 4 when you have negative exponents, okay? So the answer is 1/4. And then when it's -1, right, so you're going to plug in -1 for the x's, so you're going to evaluate f of -1, which is equal 1 over 2 to the first power, which is equal to 1/2. So when x equals -1, y is 1/2. Now we're going to evaluate it at 0. So f of 0 equals 2 to the 0 power. Anything to the 0 power is equal to 1. So when x is 0, y is 1. Now, right now, when x is 1, it's going to be 2 to the first power because we plug in the 1 where the x is. So the answer is 2. So f of 1 equals 2. Then when x is 2, we follow the same procedure. So it will be 2 to the second power equals 4. So f of 2 equals 4, y equals 4. And the same thing when x equals to 3. So 2 to the third power equals 8. Okay, now, so how do we graph it? This is a graph of the function f of x equals 2 to the x power. If you notice, right, so -2 is right here. So -2 is 1/4. 1/4 means that you're going to cut this unit from 0 to 1 into 4 places. So that's why 1/4 will be about right here, right? So it'll be right there. When x is -1, y is 1/2. It'll be right there, 1/2, right? And then when x is 0, y is 1. When x is 1, y is 2. When x is 2, y is 4. And when x is 3, y is 8. That's why, guys, these are the values. When you graph these are the values most commonly used. Because if you use something like a 4, right, 2 to the 4th power is going to be 16. It'll be way up here. That the graph will not fit on your paper. So that's why these are always some wise choices. Okay, it depends on the function, but these are the normal ones that you're supposed to use. Okay. Okay, now let's graph the logarithmic function. Okay, we have to take into consideration that in order to graph without a calculator, must convert the logarithmic equation to an exponential equation. So remember the rules that we learned two slides ago. So this is the logarithmic equation. This is the exponential equation. So example 4, graph y equals log 2 of x, log base 2x. So this, right, so this is going to be my a, right? My a is my 2. And that's my y, and that's my x. Okay, so now, guys, we're going to do a little table now. But instead of plugging in values for x, we're going to plug in for y. Why? Because if we plug in for x, you can still get the answer, but it's going to be real challenging at this level. So it's better to plug in the values for y. And you plug in the values for y, right? So we use the same values, the -2 to 3. If you notice, guys, this is what we get. and you do the same work as I did on the previous slide. So then how do we graph this one? Okay, now the one in blue is my exponential function. The one in red is my logarithmic function, which is the one that we're trying to solve, to graph, for example, 4. If you notice, when x is 1/4, 1/4, right? If this is 1, that's 1/2. 1/4 will be about right there between 0 and 1/2. So when x is 1/4, y is -2, right? When x is 1/2, right here, 1/2, x is 1. When x is 1, y is 0. When x is 2, y is 1. When x is 4, y is 2. And when x is 8, y is 3. And this one goes in that direction forever and ever. Okay? Okay, now that's how you graph a logarithmic function. Okay, now. So let's do this. So now we're going to be solving exponential equations. What I just did, guys, was like a little review, but I had to show you the graphs of why it's important to write logarithmic equations into exponential and exponential equations into logarithmic. The reason, it has like a lot of reasons, but the main one is for graphing purposes and also for solving. Okay, now to solve exponential equations without a calculator, you need to know previous topics such as perfect squares. For example, 2 squared is 4, right? 3 squared is 9, and so forth. So it's wise to know up to 10 squared. But the more that you know, the more power you have on your hands. And the perfect cubes, it's wise to know up to the 6 to the third power and stuff. Okay. And fourth roots, maybe up to 5. Be aware of that you need to know more of these, but these are the ones that are most commonly used. Most of the times, it will not get more than 5 to the 4th power. Like 6 to the 4th power will be too high, but it's always wise to know them. Okay, so exponential expression. So you have to know that a to the m, right? A is called the base, and m is called the exponent. You also have to know the exponent power rule, which means when you have a to a power raised to another power, you multiply the powers. And this is something that I believe you're learning also in 0324. Okay. Okay, now also you have to solve one variable equations. Something like this. 2x plus, let me go back. Something like 2x plus 8 equals 14. You have to know how to do that too. If you guys don't know some of these topics or all of these topics, you might run into a little bit of trouble because you have to be aware about these topics before you can move on. Okay? Okay, now, so here's a property here. It says let A be a positive real number, which means A, right? A is your base. Let A be a positive real number with A cannot be 1. Because if it's 1, it doesn't matter because 1 to whatever power will be 1. Okay, in this book here, they don't call this a specific property or rule. They just give you the property. But in some some other books they have it. This is called like the 1-to-1 property. For example, if you have the same basis, then the exponents must equal to each other. Okay. So example 5. If you have 3 to the x power equals 3 to the 5th power, right? So these are the same bases, correct? Same base. Then you can apply the rule. So then x must equal to 5. That's your answer. Okay. Example 6. Do they have the same basis? No, right? Not the same basis. So here, guys, you have to convert them to the same base. If you can recall, right, that going back to the cube powers, 2 to the 3rd power is equal to 8, right? So this is what some of the concepts that you must know. So I'm going to substitute 2 cubed for the 8. And then you're going to apply the power rule. Apply exponent power rule, which means when you have a power, a base to a power raised to another power, you multiply the powers. Now we have the same base. So now we can apply the rule. Right? And just solve. You divide both sides by 3. So x equals to 5 over 3. Okay, now, you can always check your work. Okay, what you're going to do, you're going to plug in the answer 5/3 for the x's. Right, you're going to plug it in. Okay, now here, you can use, if you want, you can use a calculator. You plug that into the calculator, but be real careful when you plug it in. If it doesn't give you like a little exponent, like a square to plug in the answer, to plug in the exponent, you have to put parentheses. So it's always wise to put parentheses on the exponent. Especially if it's a fraction. Okay, to eliminate mistakes. Or you can do it without a calculator. Okay, but with a calculator, if you plug in the calculator, it's going to give you 32. Now let's do it without a calculator. So these are some rules that you're going to know, and I believe this rule you already were exposed to it in 0324. If you have a to the power of mn, right? This is an exponent. The power is the power is a fraction, which is an exponent. The denominator is your index, and the a, right, is your base, which goes inside the radicand, and the m is the radicand raised to the n power. But it's better to do it, do it this way instead, because it's easier when you have real big numbers. Okay, so this is equivalent to the nth root of a to the n power is equivalent to parentheses the nth root of a, right, to the n power. So here, guys, I'm going to use this one here. Okay, again, this is my base, right, which is a radicand. The denominator is your index, and then 5 will be the exponent. Okay, so what's the cube root of 8? It's going to be 2, right? So this simplifies to 2, then we become the exponent, which is 2 to the 5th power. If you notice, these are already equal because this is equal to 2 to the 5th power. But anyway, it's equal to 32 because you multiply 2 times 2 times 2 times 2 times 2 5 different times, so it gives you 32. Only this time, guys, I'm going to check my work, but besides that, I already showed you how to check it without a calculator, but you have to be aware how to do it without a calculator, guys. So please make sure that you know how to do this by using this rule here, the fractional exponent rule. Okay, now let's continue. Okay, example 7. You have 9 to the x equals 27. Are they the same base? No. So you cannot use the property yet because the bases are not the same. So then we ask ourselves, does 9 squared equal to 81? No. Does 9 squared equal to 27? No, it doesn't. 9 squared equals to 81. So that means that you're going to have to reduce or have a common base between 9 and 27. And going back to the powers that you need to know, right? So you, the powers from, I think, slide number 2 or number 3. Find the common basis between 9 and 27. So I know that 9 is equal to 3 squared. And I know that 27 equals to 3 cubed, right? So I'm going to substitute 3 squared where the 9 is. And bring down the x. And now to substitute 3 cubed for the 27. Now we can apply the power rule, the exponent power rule. Right, we multiply the power, so 2 times x is 2x. And we just bring down the 3 to the 3rd power. So now they have the same base. So the exponents must equal to each other. We divide both sides by 2. So the answer is 3 over 2. And again, you can always check your answer. So we're going to plug in 3 over 2 where the x is. And you can plug into the calculator, so it's going to give you 27. Okay, now if we do it by, the other way, right? Remember the 2, right? The 2 means that it's going to be, the denominator is your index. So what's 9 squared? 9 squared is 3. And the numerator is the power, so 3 cubed is 27. But like I said, I only did it on the example before, on the previous example. And from now on, guys, I'm just going to give you the answer like you plug into the calculator. Okay, now this one's a little bit more challenging. Okay. So does 4 to the, right there at the same base to start off. 4 squared equals 16, right? It's not equal to 32. How about 4 cubed is equal to 64, does not equal to 32. You see, and already 4 cubed is 64, so it's already over, which means I have to find a common base between 4 and 32. So 4 is 2 squared, and 32 equals to 2 to the 5th power. Remember I told you guys to know all the way to 10? So then I'm going to plug in 2 squared for the 4. We'll be done the x minus 1, and I'm going to plug in 2 to the 5th power for the 32. Right now, I'm going to apply the, what's it called, the exponential power rule. When you have a power to a power, you multiply the powers. Right? So now, here we're going to distribute, right? So now, right, same base, so now we're going to apply the rule. So here we're going to distribute 2 times x is 2x, and 2 times negative 1 is negative 2 equals 5. So now all we do is just solve the basic equation. We add 2 to both sides, so it's 7. Then we divide by 2. So it's going to be 7 over 2. Again, we can check our work. I'm going to plug in 7 over 2 for the x's. So 7 halves minus 1 is going to be what? 5 over 2. And again, guys, so at this level, you also have to know how to subtract fractions and all that stuff. Fractions with integers or real numbers. Okay? So then, if we put that in the calculator, guys, it's going to be 32. Or what was the other way? Right? This is the index. What's the square root of 4? It's 2. 2 to the 5th power is 32. Okay. Solving logarithmic equations now. So to solve logarithmic and exponential equations, you need to know previous properties such as, these are, I believe, the logarithmic properties. This is called the product, right? The product property. This is called the quotient property. This is called the power property. This is the condensed version. This is expanded. And also, it also works for the natural log. The ln of x times y equals to the ln of x plus the ln of y. You see, same properties, similar properties, but just this is a log and this is the natural log. So you have to know these in order to solve logarithmic and exponential equations. Okay, so these are properties that you need to know. Okay, now, example. Okay, let's, we call example 7. We have 9 to the x power equals 27. You can do it another way. So if you guys struggle with getting the basis, to the same basis, you can always apply the rule that I'm going to show you right now. Okay. So I like to use the ln, because the ln, you're going to be using it when you get to the next chapter, for chapter 5. The log, you're not going to use again in chapter 5, but the ln, you use it. Okay. So remember that x was 3 over 2, correct? Okay, now solve by using the power property of natural logarithmic. So I'm going to use this property here. If you notice, I want the exponent to come down, right? Because I want x equals to something. So how do we bring it down? Right, we bring it down by taking the ln, right? So say, for example, the ln was not there. We take the ln on both sides, and the exponent comes down. You see, by applying the rule there. So again, we're going to take the ln on both sides. The exponent by taking the ln on both sides, it's there. So then, by the property, the exponent goes to the front. So this becomes x ln of 9 equals to ln of 27. Now we just divide by the ln of 9. And this, you can put it in the calculator. So you're going to get something like x equals to 1.5 or 3 over 2. Okay, now, this is crucial, guys. Very important, guys. Very, very important. The ln of a number is an actual value. It's not the ln. I mean, for example, here, this does not mean the ln times 9. No, it doesn't mean that. And there's a lot of misconceptions from students when they're barely learning natural logs and stuff. They think that they can divide by the, say there was a 3 here, right? They think they can divide by 9. No, you cannot do that because all this is a number together. Cannot separate them. So when you divide by the whole ln of 9. Okay? So please don't forget that. Anyway, guys, remember that was my answer, you see? So the answer is the same. And you can apply this property for every, if you don't want to, do it with the same base, you can always apply this property. It will always work, okay? But it's also good to know how to do it by using the same basis. Okay, now, so again, this is a property that we just learned, right? The u and r are real numbers with u being positive, then the ln of u to the r equals to r ln of u, right? The r goes to the front. That's what I just explained earlier. So this is an example here. So we're going to take the ln of both sides, right? Not the same base, so we're going to take the ln of both sides. Now, by rule, the x goes to the front. Now we divide both sides by the ln of 5. We use a calculator. And my result is going to be 1.2920. Hey guys, with most of these, the book and also my math lab tells you to round up to 4 places. Okay? But if it was like homework and an exam, the instructor is gonna let you know to what places to round it off to. Maybe it's 2 places or 1 place. Okay, but in the book, I believe it's always 4, and also in my math lab. Okay. You can also check your answer. All right, so I'm going to plug in 1.2920 for the x's. And if you have a calculator, it's going to give you something real close to 8. It might be a little bit over or a little bit under, but it's real close to 8. You see, so 7.99996 is very close to 8. So I know that's a correct answer. Okay, now, solving logarithmic equations continues. So here's another property that we're going to use. Okay? Let u, v, and a be positive real numbers, with a cannot be 1. If the log of base a u equals to log of base a v, right? So if these are the same log with the same basis, then u must equal to v. Then u equals v. Example. Okay, now example 10. Here, guys, we have log of x equals to log of x plus 3 minus log of x minus 1. So before you apply the rule here, you have to have a single log on both sides, right? So this, we have to simplify by using some of the properties. Okay, to apply the rule, single log must be on both sides. Use a quotient property on the right side, right? Because a quotient, remember when it's negative, right? When it's minus, it means that there's going to be the quotient property. Now, you have the same base, right? Hey guys, if there's no base, it's base 10, right? Because there's no base there. So no base means base 10. So now here you can cross multiply or you can multiply everything. Okay, now, hold on, I'm jumping the gun here. Now you can apply the rule. Single log both sides, apply the rule. So x must equal to x plus 3 over x minus 1. Now here, guys, you can do it 2 ways. You can multiply both sides by x minus 1 or use a cross product, cross multiply. So this means that cross multiplication means, right, this is like x over 1. So x times x minus 1 must equal to 1 times x plus 3. Or you can multiply both sides by x minus 1, right? And then it'll cancel on this side. So you can have x minus 1 equals to x plus 3. So here we're going to distribute. X times x is x squared, x times negative 1 is negative x, equals to x plus 3. Now, every time that you have something like x squared plus something, with x and a constant, most of the times you're going to have to set it up in the form ax squared plus bx plus c equals 0. So you have to set it up to 0. So I'm going to subtract negative x and minus 3, right? Because I want this side to be 0. Right, so that'll be 0 and that'll be 0. So here we have x squared negative x minus x will give us negative 2x, and we just have negative 3. So then here, you have to know how to factor also. Factor, I believe in 0324, they're not showing you how to factor yet. In 0324, I believe it's unit 4. But if you didn't enroll in 1324 without without being enrolled in 0324, it means that you should know this by now, how to factor. Okay? If not, I have a PowerPoint that also shows you how to factor. Okay, if you want, you can always send me an email and I can send you what I have. Okay? Anyway, I believe I also did a workshop on factoring. I can send you that PowerPoint. I mean, if somebody needs it or wants it. So to factor, right? To factor, just let me give you like a quick explanation of how to factor. This is called the second sign, right? This is called a constant. So the sign of the constant term, if it's positive, these two signs are going to be the same on the binomials. If it's minus, it means these are going to be different. If you bring the sign down, the biggest factor of the constant will always be first. Okay, if you bring it down, but you don't have to. But this is how I show my students, because I got some input from some students, and my factoring. The way I teach factoring, I get input from students. So anyway, if you bring the sign down, the biggest factor always goes first. So the factors of 3 will just be 1 times 3. And this sign also tells you that you subtract them. So 3 minus 1 is 2, right? So we get the middle term. So the 3 goes there and the 1 goes there. So now we're going to set binomials equal to 0. So we're going to set each one of these equal to 0. Here you apply the zero property theorem. But I don't want to state it here because I believe at this level you haven't been exposed to it. But all it means that this binomial must be 0, or this and this must also be 0. Right? So you set them both equal to 0. Now all you do is solve for x. So here we're going to add 3 to both sides. So plus 3 plus 3, so x equals 3. And here we're going to subtract 1 to both sides, so x equals negative 1. So these two are my solutions, correct? 3 and negative 1. It's always wise to check them, okay? To check your work. Okay, now, if you plug in, say if you plug in your calculator, just put log of a negative number, it's going to give you error. It means it's not defined. So the answer cannot be negative, okay? So when you plug them all in, for example, when x equals negative 1, I'm going to plug in negative 1 there for the x, negative 1 here also for the x there, and also for the x over here. So it's going to be log of negative 1 equals to log of negative 1 plus 3 minus log of negative 1 minus 1. And again, if you put this in the calculator, it's not defined, which means x equals negative 1 cannot be the answer. So that's not a solution. Now let's plug in 3. When x equals 3. When x equals 3, I'm going to plug in 3 for every x, which is there for the x, also here for this other x, and also for that one there. So we get log of 3, right? 3 plus 3 is 6. 3 minus 1 is 2. So then here, guys, right, again, you can use a calculator, and you're going to get the answer. Or, here, again, remember this one here? I'm going to simplify the right side. This is expanded form, right? It's expanded. Here, we're going to condense it and put it under 1 log. Remember, if it's minus, right, it's going to be the quotient property. So we're going to get log of 6 divided by 2, which gives us 3. You see, so they're equal. But this is how you use a calculator, and this is how you do it by hand. Not every time you're going to be able to do it, without a calculator. At times, it's real hard to get it without a calculator. Okay, but please try to know how to do them both ways. So 3 is a solution. Okay, now here we have another property. If a and u are positive real numbers, where a cannot be 1, then a to the power of log of u equals to u, which means, right, these right here, guys, cancels. If you have the base, right, and you have log, and the base is also the base here, this is equal to 1. You see, so u is equal to u. I mean, that's why this is equal to u. For example, here, right, we're trying to cancel the log of 3. We don't want that. So if it's a 3, right, we're going to put this becomes the exponent. You're going to put a 3 right here, and also to both sides. Let the expression on both sides of the equal sign, let these both expressions be the exponent, and the base of the logarithm be your base. So, right, so this is going to be the base then, right? So you're going to do that to both sides. And this will always work. Okay, now here, guys, if that was a 4, if it was log of base 4, then this would be a 4 here and a 4 here. Whatever the base is, that's what this becomes the base, and that becomes the exponent. Now, by applying the rule here, right? So, for example, here, right, this would just be u. So this comes down. You see, now you apply the rule. You see, this comes down, and this also comes down. Because the 3 log of base 3 of 6x minus 2 is equal to 6x minus 2 by applying the rule. So we simplify. So 3 squared is 9. We follow the order of operations. Now we're going to add 2 to both sides. 6x equals to 11. Divide both sides by 6. So x equals to 11 over 6. And again, we can always check our work. Right? We start from the actual problem. We're going to plug in 11 over 6, right, for the x's. 6 times 11 is 66. Divided by 6 will give us 11. 11 minus 2 is equal to 9. So log of base 3 of 9 equals 2. Log of base 3 of 9, right, is equal to 2. Here, you can use the change of base, or else the 3 becomes, right, we simplify 3 as 3 squared, right, and by rule, the 2 goes to the front, and 3 log of base 3 to 3 is equal to 1. Anyway, guys, you can put this in the calculator also by applying the change of base. The change of base will be something like this. You're going to put log of base 9 divided by log of 9 divided by log of 3. So it's going to give you 2 anyway. That's it. Show your work, guys. I gave you an example of almost of each one from the homework, and I also reviewed some of the concepts from earlier, chapter 4. So, questions? Hey guys, if no questions, well, I guess I'm done with this PowerPoint. Okay, I'm going to stop sharing my screen.